So today what I want to do is I want to go over all the different rules for exponents that you might encounter in a math problem. There's several. They're mostly, well, all of them are a review that you've seen before, but it's good to refresh because when you don't use it, you tend to lose it. The very first one right here is a very simple one. All of our numbers, if nothing's indicated as a power, then it's assumed it's to the power of 1, any number. So what you want to write here in this blank, we say the invisible power is equal to 1. So just because it's not written doesn't mean it's not there. Because we can write the number 3. Well, that's the same thing as 3 to the first power. But we don't write that first power. It's kind of redundant. It's assumed that this is to the first power unless otherwise indicated. Now, what's different from that over here, and there's a big hole punched through mine, if you have something written to the 0 power, that's equivalent to 1. Anything to the 0 power is equivalent to 1. So let's say you've got x to the 0 power. That's 1. Let's say you have 4x to the second, y to the third, in parentheses to the 0 power. That 0 power on the outside is for everything right here. So that itself is just 1. So our rule is for 0 degree, any number raised to the 0 power is equal to 1. This next one over here. When you have, when you're multiplying, see we're multiplying and it's a common base, two expressions with the same base. The rule is you add the exponents. Add the exponents. So when multiplying two expressions with the same base, you add their exponents. Add their exponents. So let's say we've got x to the third times x to the second. That would be the same thing as x to the 3 plus 2 or fifth power. The reason why we do that is because x to the third means we're multiplying 3 x's together. X to the second means we're multiplying 2 x's together. And then all of those add up to 5 x's, so that is x to the fifth. Nobody wants to write this out the long way, so if you remember the rule, it's a lot quicker and easier to get your answer. But now, the opposite of that is when you're dividing terms with expressions with the same base. So when dividing two expressions with the same base, you subtract their exponents. So b is the same base. You take what's on the bottom and you subtract it from the top exponent. So if you have x to the third divided by x to the second, then that would be x to the third minus 2, which is x to the first power, or just x. Because basically what it is that you're doing is you're taking out the common factors. You're reducing this. X to the third is 3 x's on top and 2 x's on bottom. So I take out my common factors, and this is what I'm left with, just x. All right, in this situation, we've got a product. We've got two expressions being multiplied, two factors, all right, being raised to a power. Well, since this is multiplication, we can individually raise each one of those factors to a power. So when a product is the result of a multiplication problem, is raised to a power, each factor is raised to the power. Now, how you're most commonly going to see that might be if you have, let's say, you've got 3x, y, and we have that raised to the second power. Then that means we have 3 to the second, x to the second, and y to the second, or 9x squared, y squared, to simplify that part right there. All right, now, if you are dividing and your quotient is being taken to a power, we say when a fraction is raised to a power, both the numerator, that's your top number, and denominator, that's your bottom number, are raised to the power. So a divided by b to the m power can be rewritten as a to the m and b to the m. So let's say we have x over y, and that is to the third power. Then we would write that as x to the third over y to the third. Looking here at this bottom, this one is taking a base number and its exponent is being raised to another power. We call that raising a power of a power. So when that happens, the rule, the shortcut, is to multiply those exponents. So when raising a power of a power, you multiply the exponents. So let's see. Let's take we'll take a problem we had early. 4x to the third, y to the second, and I'm going to raise all of that to the second power. Each one of these is going to be raised. So that would be 4 to the second power. X to the third is raised to the second power, so 3 times 2 is 6. Y squared is raised to the second power, so that would be y to the fourth. I would simplify this by writing it as 16x to the sixth, y to the fourth. Now, here's why you have to multiply. When up here, we added, this was a different situation. Right up here. We weren't actually, we had common bases. We added the exponents, and I showed you it was because of what those exponents represented, how many times that base number was being multiplied. Down here, this exponent is saying 4x to the third, y to the second is being multiplied twice. So if that's the case, then we would say 4 times 4 is 16. X to the third times x to the third. Remember, in this situation, you would add those exponents. That gives you 6. Y to the second times y to the second. In this situation, you add those exponents, and that's why we get y to the fourth. So these rules are shortcuts, so you don't have to expand this out and make it take a lot longer to solve. All right, the last thing, never leave an answer with a negative exponent. Never. And some of these may come up like when you're working this situation right here. When you subtract the bottom from the top, you could end up with a negative exponent. And if that was the case, you would have to remember this rule right here. When you have a negative exponent, you're going to change the sign of that exponent and use the reciprocal. And that's just the exponent. When the exponent is negative, you have to write the reciprocal, which means replace it. If it's written as a whole number, then that value should really be written in the denominator. And if your negative exponent's in the denominator, then its real value should really be written in the numerator. So in this situation, let's say we had 3 to the negative 2 power. Well, I would write the reciprocal, so that's 1 over 3, and then my exponent of 2 is positive. That would be 1/9. In no way, shape, or form does that negative exponent have anything to do with the result being positive or negative. It has to do with the way it's written as a fraction if we need to write the reciprocal. All right, let's do one. Let's take one that's in the denominator now. If I have 1 over 2 to the negative 2 power, I would rewrite that as 2 as a whole number. I move this up to the top to the second power, which is 4. So in this situation, when it's a whole number with a negative, it really means that is really a smaller value. It really should be 1/9. And in this one, when we have the negative exponent in the denominator, it means, oh, really, that should be written in the numerator. It really represents a whole number, not a fraction. All right, so those are your rules for exponents that you're going to be practicing on.